one, give me one, give me, one, give me one, give me one, give me one.
Good morning, Manandal. Myself, Sreevani, working as an assistant professor in the Department of Electronics and Communication Engineering in Institute of Aeronautical Engineering, Dundigal, Hyderabad. So, in the today's lecture, we are going to learn about one of the prerequisites for electromagnetic waves and transmission lines, or Introduction to Vector Calculus. We will learn in this particular session. So, there are prerequisites for electromagnetic waves and transmission lines. One is vector algebra and coordinate systems, and followed by vector calculus. So, in the vector algebra and coordinate systems case, we use under vector algebra, what do you mean by vector and scalar? Then we have learned some of the examples for vectors and scalars, as well as how to perform vector addition and subtraction, followed by multiplication of vectors. Also, we have learned in the multiplications of vectors case, the dot product representation of same unit vectors result is 1, and the cross product representation of same unit vectors result is 0, and the adjacent vectors cross multiplication will be the third one as the AZ. So, in the multiplications case, we have two different types of multiplications are there under vectors, cross product and dot product, where dot product is also called as a scalar product and cross product is also called as vector product. Now, after that, we have learned two different types of vectors as position vector and displacement vector. Then three types of coordinate systems we have learned under coordinate systems, as coordinate system is a curvilinear coordinate system in which all the coordinate surfaces are mutually perpendicular to each other. Three types of coordinate systems we have discussed, that is, for a Cartesian coordinate system, variables are x, y, z, and the cylindrical coordinate system, variables are rho, phi, z, and for the last, it is a spherical coordinate system, are also called as polar coordinate systems or r, theta, phi. Right? So, with the help of all these coordinate system variables, we will define how the point P is represented in that particular respect coordinate systems, and how the vector form is to be represented. Then from that, unit vectors, then transformation from one type of coordinate system into another type of coordinate systems are also we have learnt in the previous lectures as vector algebra and coordinate systems. Now, coming to the third type, that is another one of the prerequisite for electromagnetic waves and transmission lines as vector calculus. In this, we are going to learn about how the differential and integral components are to be expressed in delta operators. Right? So now here the delta operator is also called as gradient operator, and depending upon that del operator, we will have here four different types of terms that exist. That is, first one, gradient of a scalar function is a vector quantity. Gradient of a scalar, it is represented with del V. Del is the notation for gradient operator, and a gradient of a scalar is represented with del V. Right? So, gradient of a scalar function is a vector quantity. Then divergence of a vector is a scalar quantity. So, divergence of A means this divergence can be represented with del dot. A vector notation is given by A bar. So, divergence of a vector is a scalar quantity. It is represented with del dot A bar. Then third type of gradient operator as curl of a vector, means curl means we have considered it is in the rotation of a vector in the clockwise direction. So, curl of a vector, it will be represented as del cross a vector form is to be A bar. So, curl of a vector is a vector quantity. So, these are the three gradient operators or delta operators. Now, coming to the Laplacian of a scalar. This can be represented as del square V, or can be written as del dot del V. Right? Del dot means divergence of a del V stands for gradient of a scalar. Right? So, with the help of this delta operator, we will consider the four types of factors called gradient of a scalar function is a vector quantity, and divergence of a scalar is a one divergence of a vector is a scalar quantity, and curl of a vector is a vector, then followed by Laplacian of a scalar is represented with del square V. From this, we will learn about the Laplace's equation, then Poisson's equations. With the help of these two laws, we will find electric scalar potential values with the boundary conditions. Now, in detail, one factor of gradient operators or del operators are to be expressed in three types of coordinate systems are to be studied first. So, coming to the first operator, that is del operator or gradient operator. Generally, it is represented with del, and for the first type of coordinate system, variables are x, y, z. Then del can be given by here. Del is equal to dou by dou x into ax plus dou by dou y into ay plus dou by dou z into az. So x, y, z are the three coordinate system variables in the Cartesian coordinate system, and this del operator or gradient operator can be written as dou by dou x into ax plus dou by dou y into ay plus dou by dou z into az. Now coming to the second type of coordinate system, the variables are rho, phi, z. And we know that in order to represent rho, phi, z in the del operator can be written as dou by dou rho into a rho plus 1 by rho dou by dou phi into a phi plus dou by dou z into az. Right? So rho, phi, z are the three coordinate system variables in the cylindrical coordinate systems. Hence, del can be written as del is equal to dou by dou rho a rho plus 1 by rho dou by dou phi a phi plus dou by dou z az. Now coming to the third type of coordinate system variables are given by r, theta, phi. Those are also called as polar coordinate system variables, and it is represented. Del operator can be given for the third type of coordinate system as a spherical coordinate system. Del is equal to dou by dou r into ar plus 1 by r dou by dou theta into a theta plus 1 by r sin theta into dou by dou phi into a phi. Right? So here del operator can be expressed in three types of coordinate systems as for the first type of coordinate system variables are x, y, z, and next one is rho, phi, z, and the last one is r, theta, phi. And we have to consider over here del operator in three types of coordinate systems are given by del is equal to as in terms of x, y, z, dou by dou x into ax plus dou by dou y into ay plus dou by dou z into az. Whereas if you consider second case, differential components are d rho, rho d phi and dz, and here it will be dr, r d theta and r sin theta d phi. Depending upon all these differential components, we will write the del operators, right? Where this del operator is also called as gradient operator. Next one, gradient of a scalar. So to write the formula for this gradient of a scalar, we use the notation as del v. For the first case, for the Cartesian coordinate system, variables are x, y, z. Then we are writing the del v for Cartesian coordinate system. Then first we have to write this del gradient of a scalar, gradient operator or del operator. Then it will be dou by dou x into ax plus dou by dou y into ay plus dou by dou z into az. And we are substituting in place of with what we are differentiating means with a scalar is given as v. Hence del v can be written as dou v by dou x into ax plus dou v by dou y into ay plus dou v by dou z into az. Right? So generally this gradient of a scalar notation is represented with scalar notation is represented with v, and the gradient notation is given as del v. Hence it should be finally expressed in terms of vector. Hence the statement is given for this is gradient of a scalar function yields us a vector quantity. Right? Now coming to the second one, del V can be written as for the cylindrical coordinate system, that is dou V by dou rho into a rho plus dou V by 1 by rho dou V by dou phi into a phi plus dou V by dou Z into a Z. Z is similar to that of Cartesian coordinate system, hence it is dou V by dou Z into AZ, which is similar in first type of coordinate system also. Now coming to the third, that is spherical coordinate system, del V can be written as dou V by dou R into AR plus 1 by R dou V by dou phi into A phi plus 1 by R sin theta dou V by dou phi into A phi. This is theta, right? R theta phi. So dou V by dou R into AR plus 1 by R into dou V by dou theta into A theta plus 1 by R sin theta into dou V by dou phi into A phi. Right? This is the way we can write the three types of coordinate system variables are to be expressed in terms of gradient of a scalar yields us a vector. Right? Suppose if we have a scalar v is given as 5 into xyz value is given. We need to find xyz means the first type of coordinate system variables are given. Now we have to find the gradient of a scalar. Del v can be written as dou v by dou x into ax means dou by dou x of 5xyz. In place of v, we just substitute over here 5xyz into ax plus dou by dou y of means 5xyz into ay plus dou by dou z of 5xyz into az. Right? So upon differentiating this equation, we will be getting as the value. See, we are differentiating this one with respect to x and the other two variables need to be constants. Hence, it will be given by 5yz ax plus 5xz ay plus 5xy az is the answer for the del v. This is the way we can evaluate the gradient of a scalar function yields us a vector. Vector forms are represented in the three directions as ax, ay, az. Like this, whatever the type of vector scalar values are to be given in types of different types of coordinate system, then we use either of the formulas. Then we have to simplify. Then finally, gradient of a scalar function yields us a vector. Next, divergence of a vector. The divergence can be represented as del dot a bar. See, del dot. Del can be written as dou by dou x into ax plus dou by dou y into ay plus dou by dou z into az. Dot a means vector a can be written as ax plus ay plus az. Right? So upon simplifying these two, see dou by dou x of ax means the unit vector, same unit vector's dot product representation as 1. Depending upon that, we will write here dou ax by dou x plus why the rest of the terms are need not consider means the dot product representation of adjacent unit vectors result is 0. Hence ax with y and ax with z becomes 0. Similarly, ay with x and z becomes 0. Az with x and y becomes zeros. Then dou ax by dou x plus dou ay by dou y plus dou az by dou z. This is the way we can write del dot a bar in the Cartesian coordinate systems. See, we have to consider the vector magnitudes in all the directions as x, y, z. Okay. So this is the way the formula can be written for the divergence of a vector as del dot a bar equal to like this. Next, coming to the second type of coordinate systems, divergence of a vector can be written as then dou a rho by dou rho plus 1 by rho dou a phi by dou phi plus dou az by dou z. And third type of means del dot a bar can be written as dou ar by dou r plus 1 by r dou a theta by dou theta plus 1 by r sin theta dou a phi by dou phi. Okay, so del dot a bar is equal to, we can write the equation as like this. Del dot a bar equal to dou ar by dou r plus 1 by r dou a theta by dou theta plus 1 by r sin theta dou a phi by dou phi. Okay, so del dot a bar can be written as like this. Now consider one simple example, that is vector a bar is given as 5xy ax plus 6xz ay plus 7x square z az is to be given as a vector a. And we need to substitute, means all the magnitudes of the vectors in the xyz directions. For the x component it will be ax, for the y component it is 6xz, for z component it is az, right? So now del dot a bar can be written as, for the, means in the given x, y, z or the coordinate system variables are given. Now we need to write, see, all the magnitudes of the x, y, z directions are to be considered, and those values are need to be substituted over here, right? Then del dot a bar can be, means dou by dou x of ax value means 5xy need to be considered, plus dou by dou y of means 6xz value to be considered, plus dou by dou z of 7x square z to be considered. Then dou by dou x of 5xy. So if you are differentiating this one with respect to x, the other variables which are exist in that are treated to be constants. Hence 5y plus dou by dou y of 6xz. 3 are to be 3 constants. Hence differentiation of a constant becomes 0. Hence 0. Plus dou by dou z of 7x square z. Then it will be 7x square as the one. Then from this del dot a bar can be written as 7x square plus 5y. See, if you observe, 7x square plus 5y is having only magnitude, there is no direction. Now from this we can say that divergence of a vector quantity is a scalar one, right? This is for the second gradient or del operator as divergence of a vector. Next, curl of a vector. Now we are representing this one. For now to write curl of a vector, we use the notation as del cross a bar, right? So in order to write this del cross a bar, we will consider determinant form. So in the determinant form, and we are writing 3 by 3 matrix, means in the first row we have to write all the unit vectors in the respective directions. First type of coordinate systems means x, y, z are the variables, and ax, ay, az are the variables. Then dou by dou x, dou by dou y, and dou by dou z are the partial derivative terms. We are differentiating this one with respect to 3. Then ax, ay, az are the variables, right? So how you are going to write the equation? Means curl of a vector field is a vector one. Hence we are writing this one with respect to the del cross a bar in the form of vector, means first row, first column if you are going to find out, means ax bar is the unit vector into. So if you consider first row and the first column, the dot between these two can be considered. Then that determinant can be find out as dou az by dou y minus dou ay by dou z. Okay. Then minus ay into. Then first row, second column if you consider, determinant between these two can be written as dou az by dou x minus dou ax by dou z. Okay. Then plus az into. Now here if you consider any first row and third column, determinant between these two can be means dou ay by dou x minus dou ax by dou y, right? This is the way we can extend. See, if you observe the final one, after expanding this equation, del cross a means curl of a vector a yields us a vector quantity, right? Similarly, this is the first one, and if you consider the second case, cylindrical case, then it will be del cross a bar is equal to 1 by rho, determinant of, again same a rho, rho a phi, and az, dou by dou rho, then dou by dou phi, and dou by dou z. Why? Because in the cylindrical coordinate system, variables are rho phi z, and dou by dou rho, like its magnitudes are a rho a phi, and az. So how we have extended the same procedure here also we have to follow. And coming to the third, del cross A bar can be written as 1 by R sine theta, R square sine theta, determinant of then AR, R A theta, then R sine theta, A phi, then dou by dou R, dou by dou theta, dou by dou phi, and here AR, R A theta, and R sine theta, A phi. Like this, we can consider, right? So del bar cross A bar is equal to, so in the three types of coordinate systems, we have to write curl of a vector field is given as a vector, right? Now consider one simple example. If a vector A is given as A bar equal to 5xy plus ax plus 4x cube y az ay plus 7 x square z square az value is to be given. Now x, y, z are the three variables, means we have to consider here del cross A bar formula. So to write that equation, first del cross A bar can be written as determinant of, means ax bar, ay bar, az bar, dou by dou x, dou by dou y, and dou by dou z. And magnitudes of three directions means ax value is 5xy, ay value is 4x cube y, and az value is 7x square z square. Then in the three cases, 5xy first we have to, then 4x cube y, and 7x square z square as to be considered, which is equal to then ax into, then how you are going to write ax into, means dou by dou y of this thing means 0, then dou by dou z of 4xy also 0, minus ay into dou by dou x of 7x square z square means 14x z square, minus dou by dou z of 5xy will be 0, then plus az into then dou by dou x of 4x cube y means 12x square y, minus dou by dou y of 5xy will be 5x, right? Which is equal to ax into 0, ay into minus ay into 14x z square, then plus az into 12x square y minus 5x. See here, upon expanding this equation, upon simplifying the given equation, then curl of a vector field yields us a vector, right? This is what the third type of a gradient operator or delta operator need to be evaluated. Next, Laplacian of a scalar. To write the equation for this, the notation is given by del square V, and this del square V can be written as del dot del V. Del dot representation is divergence of a, means divergence of a, del V as gradient of a scalar as written like this. So which is equal to del dot means dou by dou x of ax plus dou by dou y of ay plus dou by dou z of az can be written as, and it is dot product with del v means gradient of a scalar can be written as dou by dou x means dou v by dou x into ax plus dou v by dou y into ay plus dou v by dou z into az, right? Now multiply, dot product between these two can be considered as dou by dou x of dou by dou x of dou v by dou x into ax dot ax. Okay, then ax dot ay and ax dot az values are to be 0, hence no need to consider dou v by dou y, dou v by dou z terms. Similarly for the next, dou by dou y of dou v by dou y into ay dot ay. And the rest will be, means ay with ax and ay with az are tending to 0, then no need to consider 2. And last one is dou y dou z of dou v by dou z into az dot az. Okay, so which is equal to dou by dou x of dou v by dou x ax dot ax value is 1, ay dot ay value is 1, and az dot az value is 1. Why? Because dot product representation of same unit vectors result will be 1, and the adjacent vectors are to be 1, 0. So depending upon that, all 3 becomes 1, hence it will be written as dou square v by dou x square plus dou square v by dou y square plus dou square v by dou z square. Right? So this can be written as del square v, or which is to be del dot del v. Right? So if you want to express the Cartesian coordinate system Laplacian of a scalar, then the formula is given by dou square v by dou x square plus dou square v by dou y square plus dou square v by dou z square. Right? So from this Laplacian of a scalar, we will write the equation called Laplace's equation. That is given by del square v equal to 0. Right? So for a special case of this one, we'll consider it as a Poisson's law. This and all we have discussed in the previous lectures. Now it is del square v equal to 0. Means generally it is a second order differential equation. Then it will be dou square v by dou x square plus dou square v by dou y square plus dou square v by dou z square equal to 0 is called as Laplace's equation. Right? Similarly, the two different types of coordinate systems, as a cylindrical and spherical case also, we have to write the Laplacian of a scalar in the second order differential equation. Now, second one is divergence theorem. So to write this divergence theorem means why we are going to study this divergence theorem and another theorem called Stokes theorem. See, in order to understand the topics which are associated or involved in the electromagnetic waves and transmission lines, now here divergence theorem and Stokes theorem also required. Right? So divergence theorem states that first, divergence theorem means the closed surface integral S A dot ds is equal to integral V del dot A dv. Right? Closed surface integral S vector A with a differential surface area is equal to volume integral of the gradient of a function as del dot A bar with a volume differentiation can be considered. Means it gives us the relation between surface to volume integrals. Right? So if we close the surface, if we close any two surfaces, then it becomes volume. Means this divergence theorem is applicable for two-dimensional as well as three-dimensional vectors. Right? So closed surface integral means integral S can be written, means this can be considered in two dimensionals as xy or sometimes yz or sometimes zx. Not only xyz, if it is depending upon the vector is given in terms of coordinate system variables, we will consider the type of coordinate systems. Depending upon that, we will write the formula for ds and dv. Right? So if you want to write the equation for here ds, so closed surface integral A dot ds means this is the case how you are going to write the formula. So if you consider the first plane as xy plane, then the direction will be in z direction. And if you are considering yz plane, direction will be in x direction, and zx plane case, direction will be in y direction. How you are going to expand that equation means closed surface integral S A dot ds can be written as, means closed, first if you consider xy plane, then x is equal to minus infinity to plus infinity, y is also ranging from minus infinity to plus infinity, then a vector A is written as here A bar dot ds, means the formula dx dy into az. Right? Why az means if you are considering here the plane is to be xy plane and the direction will be in z direction. Okay? Plus, similarly next component, if you are considering yz, then y to z A dot x direction component means dy dz into ax can be considered. Plus, third one is integral zx plane, then A bar dot dy dz ax can be written as, here z and x are the variables, means dz dx into ay can be written. Right? This is the way we can extend or closed surface integral A dot ds can be extended like this. Then integral V del dot A. So del dot A stands for here a divergence of a vector, and that one will be integrating with respect to the volume. Means integral V, how we are going to expand this one means integral V can be related as triple integral. This is the case x, y, z, whatever the variable which is given for that, then into dv formula. This can be considered as del dot A into dv. So x, y, z are the three variables in the Cartesian. We just consider in place of dv by dx, dy, dz. Why? Because volume is applicable for three-dimensional, hence we need to multiply three differential components which are in the Cartesian coordinate system, hence it is dx, dy, dz. Okay, so this is the way we can write the divergence theorem as closed surface integral S A dot ds is equal to integral V del dot A dv. Right? So this divergence theorem is also called as Gauss theorem. Right? So it is applicable for symmetrical charge distributions only. Right? And it gives us the relation between two-dimensional variables to the three-dimensional one. Okay? And coming to the next theorem, that is Stokes theorem, where the Stokes theorem and also called as sometimes Green's theorem, and it is one of the application of a Stokes theorem. Means the Stokes theorem is applicable for 1D and 2D. Sometimes in some of the application case that Green's theorem is also valid for 3D also. Now Stokes theorem is given by here closed line integral L vector A dot dl is equal to integral S del cross A bar dot ds. Okay, so closed line integral L A dot dl. Vector A can be written as we know that in the Cartesian coordinate system, vector A can be ax plus ay plus az. Right? So ax and ax, ay, az are the three magnitudes or components of the vector A, and ax, ay, az are the unit vectors in the xyz directions. Now, if you expand this one, integral L A dot dl can be written as, which is equal to closed line in. Means if you close that path, suppose if you want to evaluate the closed line integral, then A to B, B to C, C to D. A to B direction is like this. So this, if you observe the directions of all, it will be in the same directions. Hence, now how we are going to integrate this one means closed line integral A dot dl can be written as integral L. In the first length, if you consider A to B, then A dot dl plus integral B to C, A dot dl plus integral C to D, A dot dl plus integral D to A dot dl. See, upon like this, if you close that line, then it will become a surface. And it is given by here Stokes theorem. Then closed line integral L A dot dl is equal to integral S del cross A dot ds. This del cross A is given as curl of a vector. Right? So, integral L A dot dl can be extended in three-dimensional, means that will be given by integral x is equal to A dot dl plus integral y equal to A dot dl plus integral z equal to A dot dl. Right? Depending upon that, we will consider in the direction x means dl formula is dx ax, for y it is dy ay, plus z it is dz az. Depending upon the a component, we will consider the respective as x, y, z components in all the cases. Now, we will integrate then to get the value closed line integral L A dot dl. And the next one is del cross A ds. To write the formula here, integral S means suppose if we consider xy plane, or we are considering here in the first case if it has xy, then del cross A bar can be, and ds formula is to be considered as dx dy into az. Whatever the z component which is to be obtained after finding this del cross A, that need to be multiplied with az, then it becomes a constant. Then we are after that we have to integrate with respect to the x and y. Right? So divergence theorem gives us the relation between line to surface integrals, whereas Stokes theorem gives us the relation between line to surface integrals. Okay. So divergence theorem is applicable for 2D as well as 3D, and Stokes theorem is for 1D and 2D only. Right? So these are all the prerequisites which are for the electromagnetic waves and the transmission lines. With the help of all these fundamentals, the topics which are in the electromagnetic waves and transmission lines are to be easily understood. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.